Record. Okay, so we will start with a very basic concept that Wissam is asking, when do you think we'll finish the meeting? I think the main concepts will be covered by 10, so you can leave by 10 if you have something to do. So the first thing you've noticed is interfaces, the implements keyword. It's used a lot. Let me just add. Is the font size too small by any chance? Or it's fine?
It's too small.
Control plus probably will work.
I tried it, it did nothing.
Yeah, sucks to be you.
Yeah, selecting his MacBook Pro. Harry, what about this?
Yeah, it's fine now.
So you've probably
Wait,
seen
can I?
this term used implements, right?
Wait, you can zoom in the screen and zoom. Oh, yeah.
Yeah, so this class called interface name. So what is an interface in Java? I know you probably already know what an interface is, but I just want to visualize the usage because some people I notice are still confused about it. So let's take the example of a building. Suppose you have an empty building. It's just a concrete box with empty rooms in it, and you want to make that building into a hospital. So how do you go about doing it? You have to sign a contract first, right? You have to have some requirements, some functionality in the building that will make that building into a hospital. For example, okay, first you go to an agency that builds hospital and you sign a contract. Now, fun fact about Java, interfaces are also called contracts. When you start building stuff in Spring, you'll notice that contract is a word that's usually used instead of interfaces. I went through this book on learning Spring, and I think I only saw the word interface once. They just mentioned contract in all these places. So what does the contract do? It mandates some stuff. It says that, okay, if you want to be a hospital, you have to have, for example, an ICU. You have to have proper medical waste disposal and stuff like that, like, functionality. So you sign the contract, and then they won't allow your hospital to open until it has these requirements. The second you implement this contract, these requirements will come into effect. Also, you can notice it with animals. You may have noticed that there's different types of animals, right? There's like reptiles and mammals. So suppose you have a reptile, like God made an animal, and he called it a snake. But he implemented the reptile interface, which makes this snake a reptile. And it automatically brings in a requirement that, reptiles, they lay eggs. So it has a requirement to this method. You have to implement this method. Otherwise, it's just not going to compile. The reality is just going to stop because there's a reptile that doesn't lay eggs. So you can see it in this example. For example, if you're making a class that's comparable, so student implements comparable, and you give it a type student. So student is a type that is comparable with other students. You can compare a student to the other, and it automatically gives a warning. It says the class student must either be declared abstract or implement abstract method compared to incomparable. So abstract methods, I'll talk about it later. But for now, just know that abstract methods in interfaces, they have to be implemented. So for example, for the reptile, the lay egg method is abstract. For a hospital, the, I guess, has ICU or These methods are called abstract because they just in an interface they just say that okay, it's supposed to be there and it's your job to implement it. So in this case, it's comparable. You can even auto implement it by going here, compare to. This is the abstract method in this case. So this will be useful when you might be thinking, why am I explaining a topic that's from the previous feedback test? But this is useful when when you are implementing the comparator class. So anyway, let me look at this. Okay, comparator. So you already know about comparable. Comparator just means, I'll show you an example. So comparator means that this class has the ability to compare other things. Like, how do I put the difference between comparator and comparable? For example, student is comparable because if you have two students, you can compare them with each other to see which one is greater and which one is smaller. But this interface is also used for stuff that does a job. For example, a vehicle can implement, hmm, I guess runs because it runs. So just like that, if you make a class that does a job, like a comparator, you want an object that can compare to other objects. For example, this is a comparator. You put two students in it, and out comes the comparison result, which is like 1, 0, -1. You already know it from the comparable interface. So this time, instead of letting each student do the comparison, we create a class that has the job of comparing them. You could think of it as a machine, like ballots, election ballots. You put the ballots in, it counts them, and it automatically talks about the winner and the loser, or if there was a draw. So that's what comparator does. We can create like a student comparator. And the only, you don't even need this. You don't even need to implement the comparator class. We already know that the comparator, okay, that's, okay. So we don't even need to implement the interface. We know that comparator has compare. So we can do, and we can just do it like this. So why do we need to implement the comparator interface? When we can just use the method like this. So the reason is that there is a lot of different functionality that needs to be implemented in different ways. For example, there's an HTTP request maker class, there's a JSON processing classes, all that. So if we tell two different people to implement a comparator, one of them might do it like this, and the other person might make a typo. For example, you do compare. So now this is going to cause a problem because it might work in the local test, but if you have a huge code base with millions of users, people will have to come to your class and check the method names just to make sure that what method name they're supposed to use. So the people who
Yes.
created Java, they decided to standardize this. So if you want to create a comparator, it's good to implement the comparator interface.
Nothing. There's just
Hmm?
actually I didn't also get the email for it. The the emails you got, the joining one.
The joining what?
And when does the registration start? In the morning.
Yeah, I don't get what you're saying. You're in CSE, right? You guys had a
Uh,
different feedback test.
I'll be there, and then I have a class from 10 to 12, and then for the whole day I'll be there. So no problem.
Beware. Bro was on a call.
I think he's just unmuted.
Yeah.
Someone should mute Anurag.
Right, so we implemented the comparator. Now it says that the abstract method is not implemented. Now it expects a method named compare. And this is good because everybody knows that they have to look for the compare method. That's the need for interfaces. So yeah, that's a comparator class. Let me see where it is in the grand scheme of things because there is a curriculum we have to follow. Topic B1, implementing the comparator interface. Okay, it's right here. So we'll start with the comparator interface. So if you already know how to implement a comparable interface, this is going to be very easy for you. We'll delete this student comparator and go ahead and see there's a student class. So ignore the extends thing. I'll talk about it in the next topic. But a comparator, you see here, a student has a string Neptune. They have a string program, and this is just a constructor. Again, ignore the super. I'll talk about it next. But I'll just make a super simple student class here. A student has a name. A student has a Neptune. And a student has a GPA. We'll create a constructor for it. We'll make getters and setters. And here we have a basic class. So we want to compare two students, but we don't want to put the comparison because, it's already a messy class. It has 1, 2, 3, 4, 5, 6, 7 methods. We want a separate class to have the comparison logic because, it could get complicated in bigger classes. So you create another class and you call it, let's say, student comparator. And you want this to be a comparator, which means you implement the interface comparator. And in the generics, you pass in what type does this comparator compare. For example, the ballots they use in elections, they have a specific format. It's the standard ballot. It has the same names. So we tell it student. Here we have to import the class. And now it gives the warning. We have to implement the method. So it has a lot of methods. So, don't let it scare you. Just go compare. So compare, this will literally just be like how you implemented the logic in compare to. So we want to, the comparison logic we want is with their name, then Neptune, then GPA. So first let's check if they have the same name. Okay, by the way, O1 and O2 are students. So if O1 dot get name dot equals O2 dot get name. By the way, in this what I'm writing, if you have any problems, just let me know. But I think you already know what this is. I'm just gonna speed through it. All right, are there any questions about this comparison logic? I can't see the chat for some reason. Yeah. Okay, doesn't seem to be any problems. Why did you use get, not this? So I didn't use get. See, student comparator is a different class from student. We are separating the logic to a different class because this could get advanced. So instead of each student being responsible for comparing to each other, as you can see, the student class, it has no comparison logic. Instead, we created a different class called student comparator, and we implemented the comparator contract. So this means we have to implement this method, compare. So the compare method, in the students, if we put comparison logic here, it would take a different student. But instead, this is a machine that takes two students, and the logic inside is the same. Instead of this dot get GPA, you just compare the first one to the second one. And if you want, for example, descending order, so if it was on the same class, you would use this. Yep. This, for example, if the comparator itself has a number like this, then you could use then you could use this in the program, like see this dot comparator ID. This is only used for stuff in the specific class. So yeah, that's how you implement the comparator interface. Let me see what other requirements they have for the comparator interface. Okay, it says another requirement is highlights. You must be able to derive a class. You must be able to use the final keyword on methods and classes. You must be able to implement the comparator interface. You must be able to define multiple top-level classes. Okay, so you must be able to implement the comparator interface. Next, let's do, you must be able to derive a class. So I'm sure the people who have already given the HLPL2 exam, one of the main points of object-oriented programming is, uh, even I forgot. Okay, inheritance. It is one of the basic pillars of object-oriented programming. And what this means is well, we basically inherit features. And instead of me just talking about it, I'd rather give you an example. So as you know, even humans were fish at the start, right? Before evolution and everything. So suppose we have an animal class at the bottom. Animal. It has a field that says name, because every animal has a name, and an age. And I guess, hmm, what else do animals even do? I guess die. Animals die. So every animal has a name, an age, and they die, which means they just die and they get reabsorbed into the earth. So we can have a class. This is, by the way, this is this keyword, extends. So then you have an animal called dog. Dog extends animal. This automatically gives dog these characteristics. So now every dog has a name, it has an age, and it dies, like it has the default dying method. Okay, so, but dogs, they have extra behavior. So this is where inheritance comes into use. Different animals have different behaviors. For example, dogs will have a bark method. because they bark a lot. There's this dog that lives next to me and it always wakes me up in the middle of the night. Well, it's like 6 a.m. But yeah, they bark a lot. So dogs bark. Now, suppose you have another class called cat extends animal. Yeah, can you type the question in the chat? So cat will have meow. So how does this work in code? I'll show you. So first we make the animal class. Animal will have private int age, private string name, and I guess like a public void die method. So it's pretty simple method, nothing much, but to give you an idea of how it works. So this is an animal, and now we want to make a dog and a cat class, so we make a dog. So if we didn't have the animal parent class, we would have to first make this, we would first have to write private int age, private string name, uh, something that all animals have. But even then, for each animal, we have to repeat it. And, it's just, let me make a cat as well. So for cat, you would have to repeat it again, private int age, private string name, all that. Instead, you already have the animal parent class that has that stuff that has the behavior that is repeated. Behavior, that's the term Professor Adamko used. So all we have to do is dog extends animal, and boom, it already has age, name, and dies. So all you have to do is write public, oh yeah, public void bark. And you can do the same with cat. Go extend animal, public void meow, and this goes meow, meow. So just to test it out, we'll go, this is PSVM, right? Now we just create, just to show you, we create two animals. Animal anim1 is equal to new, we create a cat. And don't we have a constructor for animal? No. Okay, I'll create a constructor real quick. Okay, now we have the super keyword, which is very common in classes. So what does super mean? Super means a super in a child class refers to the parent class. So if this is the parent class and these are the children classes, any of them, if they use super, it refers back to the parent. So as we see here, the parent already has a constructor. It is animal int age string name. It takes an age, takes a string, and assigns it to the fields. So in dog, we can just create a constructor. So, create a constructor, we just say dog, or we can even ask it to create a constructor. Okay. Public dog, it takes an integer and it takes a string, and then it just refers to super. Instead of creating a dog itself, it just uses super, age, and name. So one important thing about this though is Let's see this thing. Hmm. Private string animal type. And here, okay. String. Well, do you guys know about overloading yet? Can someone tell me if you've done overloading so far? Or just raise your hand if you know what overloading is. Okay, then we'll talk about overloading as well. So for now, it just we can create one constructor. You've already overloaded constructors, by the way, in the previous feedback test. So if we have the string animal type, and if we do, it's not given, the default is just an undefined animal. It could be Bigfoot or something. So we create another constructor with all the parameters. So string animal type, the order is all messed up. Okay, so when we are constructing it using the dog class or a child class, this is where you'll see the importance of the super word. So the animal type takes parameter in the constructor, right? So here we are supposed to give the animal type as dog. So we can write here, we can pass it here. Now you can see that it causes an error. It says call to super must be the first statement in a constructor body. And that's what I wanted to show you with this whole constructor thing. When you call super, it always needs to be the first statement. Actually, I saw like two people fail the HLPL2 lab exam because their syntax and everything was correct, but super was not the first line. And a note about this in what do you say? Hmm, in JDK 22, which is what the exam uses, you don't have to put super in the first line. You can see here. It says upgrade to JDK 22 plus. So if you're using JDK 22 plus, it's not going to be a problem. So you can check in the exam if it causes an error. It's probably less than JDK 22, or I think it's JDK 22. Then you can just move it all the way to the top. And in that case, you still have to pass in the dog. So you turn this into a class variable. You can just do like, this is interesting. Cannot reference this before a super type constructor has been called. Okay, so we already know that it's always going to be dog, right? So we don't even need to store it in a variable. We can just say here, name, dog, and that's that. Super will call the constructor of the animal class. It will create an animal, but it has the animal type as dog. But for now, it's not even needed. Just create super. I just wanted to show you how super works, just in case you need it, because I want everybody to be prepared. Now, the meeting is going to end in less than 1 minute, so I'll post the new link. In I think there is going to be well, a cool down time. So I'll tell one of my friends to start a meeting, and I'll post the link of that. So see you guys in the next meeting.